All right, video 2 for 12.5 on expected value. So let's take a look at this question. So it says, you are considering options for an auto insurance policy. The insurance company offers new car replacement insurance in case your car is totaled. There is a 1% annual chance of the car being totaled. Here's your options. Which of the two plans has the lower expected cost? So let's talk about what this table means. So you have two plans, Plan A and Plan B. So a premium is the amount you pay just to have the insurance, okay, or whatever. So in Plan A, the premium is only $500 or $50, where in Plan B the premium's $60. But then there's a second part, which is called a deductible. So a deductible is if something bad happens and the insurance has to be used, then the deductible is what you must pay first before the insurance takes over. So in Plan A, if something bad would happen, if the amount you owe is more than $500, you have to pay $500 of it, and then insurance covers everything else. In Plan B, if you carry a zero deductible, that means you pay nothing up front. The insurance takes over everything. But that's why the premium is higher. It's $10 higher because if something bad happens, you don't owe a thing. All right, so that's why the premiums are different amounts. So let's talk about how we can find the expected cost and which one's lower. So if we're looking for the expected cost of A, all right, so we know we have to pay the $50. And then there's a 1% chance that we would have to pay this $500 deductible, so we're going to add 500 times 0.01. And that's if you had a crash. Now, the other 99% of the time, you don't have a crash, so you'd owe nothing. So that'd be 0 times 0.99. So just try to get that whole total 100% perspective, but you don't really need this because that's going to be just 0. So when you do 50 plus 500 times 0.01, that is $55. So that is the expected cost for Plan A. All right. Plan B, you're going to owe $60 as your premium, but then you're going to owe nothing if that accident happens, that 1% chance. And again, you do the same thing with this, but you don't need it, right? So 60 plus 0 is still $60. So Plan A has the lower expected cost. Right? So again, some people like to carry zero deductibles in case things happen, right? They expect days to be rainy often, right? But I'd say a lot of people have deductibles like this because, again, it lowers your premium and you only pay the deductible if something happens. Okay, so again, there you go. All right, so now let us use this problem to decide whether we should purchase it or not in Part B. All right, so Part B says, how can you decide whether or not to purchase the replacement insurance, right? So if we take a look at that Plan A cost, right? So again, Plan A's cost is $55. That's the lower amount. Well, we have to compare that to what you might pay if you actually do have an accident, right? So again, when you have an accident and your car is totaled, you have to then buy a new car, right? So that would be X dollars to buy that new car, right? We're going to multiply that by 0.01, which is the chance that that's going to happen. And we want to compare it to $55, right? Okay. If this cost is more than $55, right, then we should probably carry the replacement insurance, right? But if this cost is less than $55, then we shouldn't. So we're going to solve this inequality to see what value of X, what amount for our car, what range should we have for us to have or not have the insurance. So to solve this for X, we're going to divide by 0.01. All right. And when you do this, you get X is greater than 5,500. So what this is saying here, right, is that if your car costs more than $5,500 to replace, then you should have the replacement insurance. Okay? All right, again, if you don't have replacement insurance, you're going to owe the entire amount for the car, which could be a lot of money. Right? So carry the replacement insurance, and if something bad happens, just pay the $500 deductible and be on your way with a new car. So again, what this means is purchase, if the cost of the car is more than $5,500. And there you go. Okay, and then last but not least, let's do a binomial probability question involving expected value. So it says, according to the weather app on Talicia's smartphone, there is a 40% chance of rain for each of the 5 days of her vacation. How many rainy days should Talicia expect during her vacation? So what they've given us here, and again, this is binomial, they've given us this 40% chance of rain. That's our probability of a success. That's our p-value, 0.40. And then this 5 is our n value. So we're doing over n days, 5 days. And the question is, right, how many rainy days should we expect? So we have to use the expected value formula where we take the x value and multiply it by its probability. But to do that, though, we need to find the probability that it rains from 0 days all the way up to all 5 days. So we're going to create a table here, right? We're going to have this be our x value, which is the number of rainy days. Okay? And again, it could rain exactly 0 days, 1 day, 2 days, 3 days, 4 days, or 5 days. And then over here, we need to find the probability. And to do that, to find the probability of x, we're going to use the n choose r times p to the n times 1 minus p to the n minus r. And that's not n, I'm sorry, p to the r, right? How many, right? Okay, all right, so let's do that here. All right, so if our x value is 0, and really I guess this is p of, okay. If our x value is 0, right, we want to find the probability that it rains 0 days. Well, that's going to be 5, choose 0, times 0.4 to the 0, times, now 1 minus p, 1 minus 0.4 is 0.6. So there's a 6% chance that it doesn't rain. So times 0.6, that's a 4, sorry, times 0.6, and this would be to the n minus r, 5 minus 0, which would just be 5. Okay, and we're going to type this in. N choose, or 5 choose 0 times 0.4 to the 0 times 0.6 to the 5th. And again, you can do this in Desmos if you just do NCR, 5 comma 0 times, and then you just keep going on with the formula, right? I'm going to do this here. Again, if you want to practice, go ahead and practice real fast and then come back. But you get 0.00 or 0.07776, right? A 7% chance, 8% chance. All right, what's the probability of it raining 1 time? Right, well, that's going to be 5, choose 1, times 0.4 to the first, times 0.6. Now, this is 5 minus 1, which is 4. Again, these two exponents should always add up to the total number n. When you do that, you get 0.2592. So about a 26% chance it's going to rain 1 day. Probability of raining 2 days, 5 choose 2 times 0.4 to the 2 times 0.6 to the third, right? N minus r. And that's 0.3456, so about a 35% chance. Probability of it raining 3 days, right? So to me, 2 should have the highest because there's a 40% chance of raining, right? So that's a bit less than half. 2 is a little bit less than half the number of days. So now I'm going to assume that these probabilities might shrink a little bit. So let's see if I'm right. So 5 choose 3 times 0.4 to the third times 0.6 to the second. Okay, and now we have 0.2304. So a 23% chance. You can see it's kind of going down. And again, now I think the likeliness is going to keep lowering because again, for it to rain 4 days is probably not likely. So 5 choose 4 times 0.4 to the fourth times 0.6 to the first. This is going to be 0.0768. So again, about another 8% chance. And then the probability of the fifth of it raining all 5 days is 5 choose 5 times 0.4 to the fifth times 0.6 to the 0. Okay, and that's going to be 0.01024. So pretty much a 1% chance. Probably not going to happen. So now we must do the expected value formula. And I'm going to do it very short-handed right here down here. So the expected value is going to be the first x value 0 times its probability. 0.07776 plus the second x value 1 times its probability 0.25, not 0.5, 0.2592 times plus plus, and I'll go all the way to the last x value, so 5 times 0.01024. And again, I would have 2 times 0.3456 plus 3 times 0.2304 plus 4 times 0.0768 plus 5 times 0.01024. When you do this, you get an answer of 2, which means we should expect it to be rainy on 2 days. 2 rainy days. Now, there is a shortcut for all binomial probability situations. If I'm looking for the expected value for a binomial, you just take the n value and you multiply it by the p-value. So, if I have n is the number of days, 5, my p-value is 0.4, 5 times 0.4 is 2, which matches that answer. So this is a shortcut way to find the expected value for any binomial situation. All right, thanks for watching. Good luck on the practice.